Yes, sir. Please start, sir. You can go to PowerPoint and you can start. Sir.
You can hear me, right? You can see my PowerPoint? Can you see me? Hello? Hello, can you see me? Hello? Balaji, can you see me? You can hear me also, right? Thank you. So, hello everybody. Welcome to this session of IIT Madras Smart Enterprises of Tomorrow. Hopefully you can all see me, you can hear me. So for next 30 to 40 minutes, what we will be doing, we will be taking a look at some of the important characteristics of the smart enterprises tomorrow, the way the enterprises are shaping up worldwide, and we will also take a look at some of the characteristics of making it happen. So let's keep rolling. So, all right. So, what is a smart enterprise? A smart enterprise is broadly referred to also as cognitive enterprise. In IBM, that's the word that we use, but whichever way you use it, the most important thing about smart enterprise is that it's a business that's smarter than the smartest people running it. What does it mean? It means basically that you have the right set of people, process, technology, right set, the optimum combination, because of which the working of the enterprise is now optimal. Now let's take a look at it. You have always this people in any large organization, enterprises, usually most of these processes are suboptimal. The output is suboptimal. Now this is not an easy task. How do you go and get all of them working in tandem and making it happen? So to do that, humans alone cannot do it. We absolutely need the help of machines. The reason being, if you want to optimize something, there's a whole bunch of data coming in. Now that data needs to be crunched, insights have to be generated, and based on that data, the data drives some of these processes. That data is actually so huge, massive, structured, unstructured, whole bunch of them, and we will get to see some of that very soon. So when you have this massive amount of data, think about it. How can humans look at it? Humans have the first problem, that is the monotony. They get fatigued. If they look at the same data, similar data over and over, they tend to make a whole bunch of mistakes. B, we cannot comprehend that massiveness and then generate. If it's a small data, we can find the patterns. We have to have a different set of tools and techniques. And today, that is nothing but machine. So the question here is, how do we go and teach machine to perform like humans? So let's go to the next slide. This is interesting. Let's see, how do we need the enterprise to be cognitive? Why do we need it, first of all? Well, for the simple reasons that the market conditions, if you look at the market conditions today, the customers, they need to experience a personalized storefront. What does that mean? Here is a Amazon customer. You right now, this is lockdown period. The whole bunch of things keep happening over Amazon retail, Flipkart. There is a whole slew of online retail stores. Now, when you go there, the biggest thing is we are all suffering from information overload. So how do you go and get to order the right thing with the minimum number of clicks? How does the storefront show you something that you need to see, as opposed to a whole bunch of other junk that you just don't care about? So this is a very important thing. A personalized storefront, any channel, anytime. You want to do it over mobile, you want to do it over your laptop, whichever laptop, or even for that matter IVR, that is the voice recognition, intelligent voice recognition system. Usually we don't do that for ordering retail stuff because we don't get to see it. But so we all want to see something before we order. But regardless, the most important thing is, when the customers come to your site, they don't have time. They want to get to what they desire for at the minimum amount of time. To do that, you have got to understand what does this customer want? What is the intent today? What does he or she usually buy? Or the people like him or her buy? You saw that in Amazon, right? That like people like this buy things like that. So that's one aspect of it. So anytime, anywhere, any channel, they expect the enterprise to provide a platform using which they can easily order or get what they want. Now, in case of B2B enterprises, business to business enterprises, it's a little bit different. They may want to trade, and that is where the ecosystem partners are. They may want to trade on that platform, have a little bit of exchanges. They can do some chats and stuff like that. But at the end of the day, minimum time, minimum interaction, maximum use of whatever little time I spend with that enterprise, and I want to get the maximum value out of it. Now, to do that, it's not that easy. Because if you go and talk to one human being, that is not a scalable thing. You absolutely need machines to do that. And hence comes, and that's where the artificial intelligence, analytics, they all step in. They work with humans side by side, to make that processes happen in such a way that you get the best experience. So experience is a very important thing, right? Because they want to experience it. Now, this is the view of the enterprise talking to its customers, its ecosystem partners. But any enterprise or business, there would be a whole bunch of employees also that they have, right? And the employees also need to have the right experience. Look at like in IBM Corporation, right? We have some 400,000 people. They need for their own facilitation for the own activities. They need mail system. They need HR system. They need customer relationship management system. So that's the employee. So enterprise, two sides. One is internal for the employees. You need to have certain platforms, certain tools and techniques so that their experience is kind of maximized. And then on the other side, the customers and the ecosystem partners, when they work with the business, they also should get that way. So these are the drivers. Does an enterprise today, a business house today, do they have it? No. Hardly 5 to 7% of the enterprise worldwide and we go around the world. We consult for many of our. They are definite. They think that they have it. Majority of them, they are putting those things in place, or they are thinking about it. They are planning about it, and the first thing that comes to their mind, if we want to go and make these things so intelligent, so smart, so that we can create that experience, we need to know how to crunch data, how to process data. That's where the data scientists come in. That's where courses like this being offered by IIT Madras comes in, or some of the numerous interesting data science things that are there on so many channels all over the world, internet, university campuses, right? Because this data is big, it's massive, it's moving, it's all the time. Data has its own life, and then you have to get the right value out of it at the right time to make it happen. Now, let's look at a few things. If data is at the heart of new age enterprise, and the second statement on the left we are making, it needs decision systems, smart ones. So obviously these smart ones, they have to recognize patterns, just like humans. Humans say, oh, okay, looks like I see this guy is going to explode now. Why? Because I have not given him the service and he's now very unhappy. This customer, this lady, she is just going to stop shopping with us, all the more because all the time we have not interacted with her at the right time. Now humans can recognize that patterns. How can your machines do that? It's not easy, right? But we can teach the machine to do that, and we will get to that in a little while. Now, let us look at the cognitive decision systems. To do this kind of thing, you need to have people process technology working together. This is a very important thing. People process technology. So, in the old world of consulting, we used to talk about people process technology. In today's world, there is an added element called data. Now, you can all see data is right in the middle because everything revolves around data. This is fantastic because earlier the data scientists and all, they would be just looking at the data, coming up with a little bit of insights, and they say this can be done. Today, data is, everybody is touching it, but the most important thing is they are getting insights real time, and it is flowing from system to system, process to process, people to people, real time. Just now, just as we are doing this YouTube, this streaming, right? So data is the new gold. This is at the heart of the digital economy. Now this has got 4 dimensions, right? As I was saying, it has got volume, it has got variety. Why volume? Of course it is large. I mean, there is data within the enterprise, there is data outside the enterprise, there is data of various forms, some of them in your RDBMS, structured data, your Excel spreadsheet, some of them in your emails, or in somebody told something, over the water cooler having water or tea, and that has been captured, and that also is your data, right? And the data has to be the right type. Veracity means it has to be good data, a data that can be relied upon, right? So the data is internal, external, structured, unstructured, curated. Why curated? Sometimes the data keeps coming in all over. You do a search on Google or Wikipedia, there is a massive amount of material there. Which one of that material you would like to lock in? That depends upon, you are just like you read in the morning the newspapers like Times of India, the Hindu, the Hindustan Times, Indian Express. Why do you do that? The Deccan Herald. Because when you read these newspapers, you trust the editors to have curated the data for you, right? So that you get to glean and generate insights out of something that can be trusted. Somebody has taken care of it for you, beforehand. And then there is the world of uncurated data. Curated data is very important for artificial intelligence Because if you start doing analytics out of anything, it would be a garbage in, garbage out problem. So there would be a massive amount of garbage out of that, fake news, bad news, malicious news. Out of that, you would be generating all kinds of wrong insights, right? And hence, it has to be curated. Now, the data is very interesting. It can be initiated by humans, like in social media blogs, like the talks that we are doing, and all kinds of things. But more and more, something very interesting happening. There are sensors being placed all over the cameras, the audio feeds, the manufacturing plants. You will have sensors here, there, everywhere, taking temperature, pressure, and telling, oh, looks like the temperature of this warehouse is so high now that all the cheese that I'm putting all the cheese that I'm putting in my refrigerator, the refrigerator is not going to work here. It's so hot inside. Or let us take the hospital system. It's so hot that it is adversely affecting my patients, right? So sensor generated data is going to be massive. And one interesting thing of sensor generated data, it keeps on going and generating that same pattern, same thing. Oh, the temperature is hot every few seconds. So you need to have right filters, right analytics mechanism to understand where the data is the same stream, same thing being repeatedly sent over the wire, versus where there is a break in the sequence. And that's where the pattern recognition algorithm comes in. The moment you see a break, the moment you see that it's a different pattern, you know that there is something interesting now happening. These are the moments, so these are the time zones that you're going to look into. Now, the data can be naturally occurring, right? Earthquake data under the sea. The tsunami that happened sometime back in the Indian Ocean. So these are naturally occurring data. The data types: text, numeric, acoustics, that is sound, optics, that is vision, haptics, that is touch. Almost everything out today, it is being measured, or there is some data being generated. And if there is data, you can do something interesting. So data-driven thing is a very important part of the smart enterprises of tomorrow. And hence, all the, mumbo jumbo analytics, this, that around it. So it's so important. Okay, now let's look at some of the people. Of course, we need data scientists, but what are data scientists gonna do? Just go and write programs? Of course not. They are going to develop interesting models so that those models come out with very interesting outputs and you can feed them? Of course not. A massive amount of data scientists today, they first look at the data, see whether it is good data, reliable data, they manipulate it, and finally it is now fit for modeling, it feeds into neural networks or whatever it is. And once you create that infrastructure of a learning system, learning networks, there are techniques for that. We will see that later. Deep learning techniques, reinforcement learning, a whole bunch of them. But once you configure that, now you have got to maintain it. Like you have got to maintain everything. You create a beautiful park in your neighborhood, you have got to maintain that park. You should not pluck flowers, you should not treat on grass, you have got to, similarly for learning networks, you have got to go and teach it, train it, and keep monitoring it so that it does not do something wacky, something, completely outlandish from time to time. So once you go and you are happy with its learning capability, you let it go. But even then, just like Oracle databases and all, if anybody has worked with databases or RDBMS or DB2 and all, people had to go and periodically tune and test the performance. You still have got to do like that. Okay. So now, and of course you need the right kind of technology. As you see today, there is technology, Internet of Things, edge, cloud, very important thing. Today, if you see, cloud is ubiquitous. It's there all over, everything they are trying to do. But the next thing that we are also see, that is the edge networks. The edge networks are actually near the place of action, local. So if cloud is a centralized kind of central government kind of thing, all data goes to a big central server, and there all the processing happens, and it comes back to the peripheral, the the boundaries of that system. Edge is something very interesting. Edge the data is processed, data is analyzed, data is consumed right at the place of action. Like just now, when I am dealing with, for example, that Amazon online thing or any other online retail stores, we will see that there is some action happening right then and there. All the data does not have to go back to the back end. Some data can be processed right then and there, and some intelligence can be afforded straight away. The drones, like the smart drones that go across the agricultural fields and see that whether the crop is growing right, whether there is a disease happening in the crop, whether it is ripe for harvesting or whatever. Sometimes they are very well equipped with that edge intelligence. So the camera does not only takes picture of that field, the camera is also processing, and right away along with that processing, it goes to another place where it should go. Surveillance drones are basically fantastic examples of this. So we talked about the data very quickly. This is like the whole bunch of data is unstructured today. As you see, there is an exponential increase that's happening, and we all understand that. So two important things of smart enterprises. We talked a little bit about it, that one view is the outside in. The customers, wherever they touch your business, you need a platform for them, omni-channel, any place, anywhere, anytime, with little human intervention, maximum digital assistance, robots trying to help the people, that kind of thing. And then there is this inside out view, that is, just as I told, we IBMers, we have our own HR system, marketing systems, communication systems, finance system, payroll system. There is a whole bunch of systems, the platforms within the enterprise, which we call inside out. Examples, some fantastic examples of outside in. SBI, State Bank of India's YONO mobile thing, tries to understand you, help you with the mobile banking. We IBM, we had done a project with Lotte, very much like Amazon. Lotte is a Korean company where, Friday night, a young lady, she wants to go out on a party, and she wants to say, what dress should I wear tonight? It's a little bit raining, and it is summer, and the kind of trends that is going on in Seoul, Korea, this. So she just asks the Lotte backend engine, and the backend engine comes up with some fashion recommendation based on her previous buy, based on the picture of a wardrobe she has uploaded using her mobile, based on the weather that evening, and based on what kind of fashion that's going on in Seoul that summer. So very interesting things. Cognitive fashion. So smart fashion. That's the kind of thing. Very interesting. You can use it for culinary things, for chefs, cooks, and all that thing. These are the smart systems of tomorrow, and I'm pretty sure, people who would be going through this, this course, they would be starting some entrepreneurial things. There are so many things. Now, IFCO Tokyo, one of the insurance companies we work with, they also have some very smart ways of, for example, processing claims. If you take, and this is a very interesting thing, the auto claims thing. You get into an accident, and you just come out of the car, you take a picture and you tell, hey, tell me, the insurance company, how much money should I pay to say, and the artificial intelligence agent, they have all the data in the past, they know your behavior, they know the weather pattern right there at that time when this thing happened, and all these things, and they know the kind of damage that it is a dent in the bumper, and it says, okay, some 7,000 rupees you have got to shell out to fix this whole thing based on my previous things of such types. So, and there are many interesting nuances there, many complexities there, like in a bad light, we cannot process that thing, that there is too much glare when we took that picture, a whole bunch of interesting situations. So if you look here, if we look deeper into technology, we started with mainframes, IBM, big mainframe machines we used to have, many other companies playing that. Then we had the client servers of 90s, 2000. There used to be Power Builders clients, I used to remember. Then we have the cloud. And I told you that something is going to happen very fast, the edge computing. Now this is interesting. Why? Because if you needed intelligence, artificial intelligence, aware data scientists, savvy with analytics in the cloud, now you will need more of them on the edge side, because each device will start actually processing, will be more intelligent, more cognitive, and they will start talking to each other, not always necessary going to the cloud, right? So these are some of the things that we have got to think about. Okay, now the decision systems. The decision systems, it is characterized by features. So look at this decision system. This is a home thing, home assistant. Look here. Like for example, there is this home assistant talking to Amazon Alexa. Very interesting natural language processing happening here. And based on the data, certain interactions, you go and for more actions, you send it to a backend platform. So something is happening here at the edge and something is happening on the platform. Similarly, the agricultural drones, if you see, the surveillance drones that we were talking about, it is going and following, for example, the people it wants to follow. So it's very interesting, like in case of, situations where you have to really, say, protect your border, for example, national security, right? These things can be very helpful. And then you have, so cloud plane out here, the edge play out there. In both the places, you need data scientists. And in both the places, you have the same problem, taking data, understanding it, creating models, and making it learning models. That's where it is. Okay, so what are the building blocks that we have in decision systems usually? The usual building blocks are, you have advanced analytics, the machine learning, mathematical optimization, simulation. What is optimization? I want to do this thing very well. Like I want to go and increase the literacy, uplift the literacy level. But I have a few constraints. The constraints are, we may not have that much amount of fund, that many number of schools, that many number of teachers, that much amount of books available. Now COVID, no classrooms. How do you go and improve your learning capability? You do that, so you maximize your fund allocation. You optimize your fund allocation to maximize the learning, the literacy level, the learnings, and with certain constraints that you can't do this, you can't do that, you can't do that. That's the optimization. That's a class of problem. Whereas simulation is something different. Simulation class of problems, they try to see a certain things in a microcosm. They try to go and mimic a larger model, like a weather model or an earthquake model, in small little micro models, and try to understand what are the complexities there, what are the drivers there. So there is a class of predictive analytics, there is a class of prescriptive analytics where you prescribe what should be done, and then there is this class of simulation, neither predicting nor prescribing, just understanding it better so that you can provide better solutions. So this is, and for each one of them, you need mathematical techniques, certain rigor that you have to follow, and this is what this kind of, formal trainings are required. If you look at artificial intelligence, so the artificial intelligence, the neural networks, feedback learning, deep learning, you'll get to that. This is tough. This is not easy. That is, you see a pattern and then you remember the pattern, and when you see a change in the pattern, you start relearning it. It's not easy, but there are techniques to do that, and we will get there later. And here is the data engineering, which is the most important. For those models, massive amount of people we need who can actually do the plumbing underlying, the data lakes, the data warehouses, the databases. How do you lay out the data? How do you make data retrieval fast, quick, easy? How do you move data from one system to another system? And finally is the architecture. These are probabilistic systems. These are systems which may or may not do. How do you go and create an overall architecture and a storage and orchestration of different processes there? So these are some of the examples of AI applications in industry. And for some of you who are worried about whether we should, let me put some light on. Okay, looks like there's some problem here. Okay, so examples of smart AI applications in industry. If you look here, from banking, insurance, automotive, everywhere. And there is a whole bunch of things you can see here. Fatigue detection, a pilot flying for hours and hours, a truck driver, driving for 14 hours, 16 hours. Fatigued, right? How can a camera take a picture, and from the expressions, from the face, you can understand this pilot is fatigued, right? Fantastic problems. Now, it is not just for one big corporation like a plane or Mercedes-Benz or BMW. They need to do fatigue detection, right? This kind of inside vehicle fatigue detection can happen everywhere. And it does not have to be also always in the car. It can happen even with your loved ones at home. Your mom, your wife, your near and dear ones. Are they fatigued the whole day? They are working, and they are really not saying that, but it is writ on their face. Can a simple home automation system take a look at their face and say, hey, you know what? You are really tired now. Can you do a little bit of rest? So this kind of, personal touches, not necessarily. This is where the entrepreneurial thing is. Manufacturing, bottleneck analysis, huge amount of cars piling up, nobody buying, for example, due to this COVID situation, for example. Now, how do you go and tweak the right places in your manufacturing process so that you do not end up, paying for massive warehousing? So what are the things that you need to do? So it's all over the place. And if you look at it, the applications are there. You just have to think. And this is where probably the most important thing comes. The two most important things while you do data science and thing. One is imagination. It starts with imagination. How can I go and apply some of the interesting techniques, so natural language processing, graph theory, vision, all those mathematical stuff? Where can I go and apply a little bit of it to make the problem interesting, to turn it into a quantitative, really a data-driven system that looks at certain things, real life, real signals, detect patterns there and come up with an automated response. So imagination, imagination, imagination. You will come across this problem almost all the time. How can I go and apply some of these interesting things in this area, that area? Garbage collection, something that is happening. There were snakes in Bangalore in summer in our apartment complex, and we stay near a lake, and the snake came in. So how can you go and put a small camera within the bushes and the herbs and see if there is something that looks like a snake, that moves like a snake, that wriggles like a snake? Call it out and say, hey, you know what, there is a snake here, don't kill it, don't go near it, call the forest official, let it be taken away safely. So that kind of thing is imagination. The second problem that is very interesting is articulation. So when we do data science, we learn all these mathematical techniques, and then you have got to imagine, where do I apply it? And you have got to go and imagine how to make it, sell it, how to make the consumers aware. Excuse me. What can be done? How to adopt it? Because it is not good enough that you imagine. It is very important everybody else in your ecosystem, they get to understand that imagination, and accordingly they can do something interesting to move the society and their business move forward. Okay, so okay, can you see it still? A little bit of a situation here, transition again. Okay. Can you see my screen?
I am not on the call, sir.
Okay, so who can tell me whether anything is wrong here?
No, went well, sir. No issues were there, but question answer is there in the Google Sheet.
No. Whether I am seeable or not, can somebody please check it?
Yeah, I am checking it, sir. I am already in the video. I am checking the YouTube video. It's showing good.
It is showing, it is changing. Can you hear my voice there, please?
Yes, sir. I am still there.
Okay. Hello.
Everything is well, Kingshuk.
Thank you. Okay, so okay, so with that, we will actually end up this thing here. Let's see if there is anything else I wanted to cover. Yeah. So one final thing I wanted to cover, that is the top 3 AI implementation patterns in smart enterprises today. One is the digital conversational assistants. This is very, very popular pattern. Why? Because if you look here, all over the world, suddenly, due to this COVID thing, humans could not go to the call centers. And these call centers could not route their calls to homes. They were not equipped always to do that. So during that time that they reconfigure their call centers so that, you can take the call, service the call, the level 1 calls from anywhere you are sitting, like in your home or anywhere else. But, during that time, one interesting thing that we saw, the conversational assistants came in very handy. You don't have humans. In Italy, for example, in New York City, where people have been dying in a big way, how do you go and still keep the conversations going, help your customers? So automated patterns, automated text-based, either you talk, but voice is a little bit still, we are getting there, but it is the, you text, you start typing in your problem, and some automated assistant assists you. So that kind of conversational AI, it was very popular. Recommendation engines, more and more popular. Started out with certain online retail commerce. Now it's going all over the place. Almost every company, wealth management, doctors, engineers, lawyers, everybody at some point of time or other would love to be assisted by some system that can take a look at this massive amount of data and start helping them a little bit more. Our Watson Health was a step in that direction, and there are many other companies that are working in similar areas. Legal stuff, LexisNexis, for example, massive amount of law and legal and compliance things. You start looking at them and you try to recommend. And the third area is back office process optimizers. This is a very interesting area. You see this invoice processing, a massive amount of documents here, there that comes. There is a little bit of an oil botch on the on the invoices that you got. Can AI go and tell me that what is hidden under the oil? Because AI has been looking at that kind of invoices for last 5 years all the time. It is trained now, and probably it can predict. Probably this is the kind of text you can expect under that oil, that smudge. So, but more importantly, how can you go and read the invoices, take the numbers out of it, and start pushing them into back office financial reconciliation systems, customer relationship system? So the potential is absolutely, it's endless. It is just a beginning of the AI thing that we are seeing today. So, and one final thing, the 3 learnings from decision system. You learn the AI basics for identify the AI implementation scope. A big thing today is many business leaders, they want to go and do AI, but not necessarily they understand AI. They take wrong use cases, business cases, and hence, and even we sometimes do this mistake. So it's important to understand the fundamentals, the basics. It's absolutely, there cannot be any deviation from that. We understand the basics, we understand how it works. And the second thing is, when you go and you train an AI machine, you have to do the right contenting. You have to pick the right content, as opposed to feed any data to it and that garbage in, garbage out problem. So a lot of people we need there, lot of skills. And finally, we need some top subject matters experts. If in LexisNexis they are coming up with a system for compliance checks, automatic or legal thing, or argumenting, we have some fantastic things that we are doing with the debating. How can people argue and debate? So, but this kind of thing, you need subject matter experts who really understand that area and can teach the network exactly the right behavior, like the way we teach our children not to curse, not to be polite, be polite, not to be irreverent towards the elders. So to do that kind of thing, you need the right set of experts, right set of policies, guidelines, ethics. AI ethics is a big area, and this is what we would love to see going forward, and there's a lot of need there. With that, I will conclude my talk here. I really appreciate your help, your time to listen me, and I will take some questions now. we will go a little bit random selection of the questions, because probably I won't be able to solve all of them. So as I go and pull up the questions, okay, so one question I see, even after passing the qualifier, okay. Sir, so let me take this question. I'm currently doing master's degree in chemistry. I want to know what are the career opportunities of data science in the field of chemical science, pharmaceutical industry. A lot, you know. Hello.
Sir, in OBS, you can click on your full screen, sir. We are seeing your screen very small.
Oh, the question, you want to see full screen?
No, your video, sir.
Oh, my video, just 1 minute.
In the software, we need to click on transition, sir.
Can you see me now?
Yeah.
Can you see me now?
I will be in some delay, sir. Fine, sir. If you can, fine, sir. You can go ahead, sir. Yeah, fine, sir. Thanks. Yes, sir.
And let me put the lights on. Okay, can you see me now? Hello?
Sir, you can click on the transition again, sir. I think you click twice.
Is it okay?
Fine, sir. Please go ahead.
Okay, so the question is, can we do it in chemistry? This is master's degree in chemistry. The answer is absolutely yes. And actually, chemistry is one of those fields which excite me. If you look at, for example, the next generation drugs, the pharmacokinetic simulation, even the choosing the right drug molecules, it's a play of simulation that we talked about before. Predictive analytics. What is the probability that this drug molecule can indeed address this kind of disease? The third thing in chemistry, for example, especially in pharmaceuticals, a lot of drugs. So as soon as there is an adverse reaction for a drug, somebody has got to go, and in some place, some country, some corner of the internet, somebody has gone and put an adverse reaction about a certain drug that your company has launched. How do you go and find that out? You kind of, you keep crawling the net, you find that natural text. No human can go and do that rigor. It's only a machine. They can hone in into those snippets and bring out those adverse reactions so that the company is aware, and they can record it and take corrective action, whatever that is necessary. So this kind of things in pharmaceuticals, probably one of the areas, and now with this COVID situation, we all feel that, how much we love biology, how much we love pharmacy, how much we love vaccines. We can't tell it, right? And analytics is all over the place to help us out. From, just as I say, adverse reaction, drug launches, testing, the drug testing. Before you do that, you have got to go and take it through a whole bunch of tests on the animal testing, human testing, and you have got to know the statistics very well, so that you can say with 99 or 95% confidence interval that this drug really works, right? You take two samples and you take, for example, people with placebo, people without placebo. You give the drug, the real drug, to one group, and supposedly, but not really, the drug, the placebo, to the other group, and you see how they react to it. And then you have to do a statistical test using things like ANOVA, and there are many more methods there, right? And but the analysis of variance, and come up with a confidence interval for that drug. So pharmaceutical industry, probably one of the most important places where we can do analytics for the advancement of people and science. Okay, so let's take one more question. What is the future scope for freelancing in data science? Will this be a game changer course in shaping freelancing as a career, since now everything is online and freelancing is working remotely? I do not know the exact answer, like whether, because a lot depends upon the social situations and all. But the capability, absolutely yes. If somebody really understands this thing, I have a friend. He's a data science freelancer for last. Sometime he freelances, sometime he goes back to big companies. He's a medical doctor, and then he has done his biostatistics from a US university, and he works out of in New Jersey. So sometime he works for top big companies like GlaxoSmithKline, Pfizer, and all, and sometime he goes and just freelances when he thinks that. So and he's really good at it, because he understands medicine and he understands statistics, right? So if you are really good at it, absolutely, I think yes. But it also depends upon a little bit of the socio-economic situation. If if there are a lot of unemployment and all, probably people may go for jobs. So, and there will be a lot of competition there. Okay, agriculture. Of course, just as I said, those drones going over the agriculture, before you can even, human eyes can pick up that the rot is setting in the crop. How can you go and use some of the optics and artificial intelligence driven drones to go and do the surveillance over the agricultural fields, and the crop prediction, the weather prediction. That's a very important thing, right? In IBM we bought a company called weather company, which has got very precise data about weather, which is a big factor for agriculture, floods and all that thing. So absolutely yes. Okay, let's see. So I see I am LLM, a practicing advocate in Supreme Court of India, and more than a decade. How this goes? Absolutely, this is a fantastic question, because if you were an advocate and if you want somebody to prepare the briefing for you, think about, can a machine help you do that? Go through all the literature, all the stuff. Hello.
Hello, sir.
Yes.
Sir, please, your camera angle is not far about, sir. Can you
Okay.
Build this only.
Is it okay now?
Yes, sir. Fine.
Okay. Thank you. So can can the can you do that? So all the briefing, uh, that is one aspect of it. The second aspect of it, arguments, the counter arguments, building up logic. This is one fantastic area of research that's going on. How can you go and look at all the case histories, all the you know things, the past such judgments and all, and how many books? I mean, one thing that amazes me: how can a lawyer? I mean, they are like steeped in. There's so many books all over, right? And you have got to remember so many things. So it's not easy, but machines can do those things much better for you. It can read up all the thing if it is all digitized book, not really read up the book and flip pages. It can go through all that literature and find out on such and such year 1970s such a criminal case, the three arguments that happened were actually constructed this way, and this is probably something similar. And the logic, which is the fundamentals of such things, like A implies B, B implies C, hence A implies C in such a case. In such cases, that implication logic, it transfers from one statement to another over that thing, over the chain, right? So if you can turn that text into some mathematical model, solve the problem in the mathematical model, and then again turn it back into the text, this is what science is about. You see a whole bunch of stuff around you, your sight, your sound, you hear voices, you see pictures, and then somebody goes and takes all these things, blends it up, and formulates a mathematical problem that kind of mimics reality, that kind of models reality. Once it is in the mathematical model, then you have all the techniques and all to solve it, and you will learn in such formal courses. But once you learn and you solve that problem, now you have got to transpose it back to the real life, and that's where probably the the art lies of consulting. So data science, you have to learn the techniques, and you have to know the subject matter to do that translation from real life to mathematical model, from mathematical model back to real life, so that you are always connected with the business end to end. And absolutely yes, law is one area where you can do a whole bunch of stuff. One final question that I will, so let me go through the thing a little bit. There is a question on bioinformatics that okay, so having 10 years as full stack developer, Amit Kumar from New Delhi, he asks, I am very much interested in mathematics. That's why machine learning attracts me. Will it be a good move to switch career financially? So absolutely yes. First of all, it's a good move anyway, because it's an interesting area, and financially probably yes, because this is one area. I talked about edge computing, I talked about data, I talked about analytics, and you cannot go and do them without some good understanding of mathematics and statistics. So if you are a programmer, you have an advantage, because now you go and you look at all the math stat, all the thing, and you turn them into programs so that it can be automated. So all the smart models are now automated, embedded in a program that can run. Is it a good move? Absolutely yes. Okay, this is 7. We are on the top of the hour. We will finish here. Thank you very much. And for all the people who have attended it, the only thing I can say that I'm many years doing this role, this kind of thing, data science and all. I'm a computer science guy, but moved into operations as a data science later on. And all I can say, this is a fascinating field, a fantastic field, and don't be intimidated by every time you see a mathematical symbols. It's not at all tough. Just calm, cool, go through the logic, you will get it. It's no rocket science. It's a fantastic place to be in. With that, I thank you very much. I wish all of you wonderful future ahead, and I can pretty much tell you right today, if you're really into it, heart and soul, all of you will do very well going forward in your life. Thank you.